And section 11.4, we're going to be solving applications. With systems. And let's go ahead and take a look here. What if we had two numbers that total 54 and have a difference of 8? So this means the first number plus the second number has to equal 54. And the first number, let's see here. So two numbers, they total 54 and have a difference of 8. So let's call the first number X and the second number Y. We add them together, we get 54. Also, if we subtract those numbers, we get 8. So this is already set up like a system. We could use elimination like what we just talked about, and if we just add them up, we get 2x is equal to 62, and x would be 31. That would be the first number. If x is 31, we know x minus y is 8. Eight minus 31 is negative 23, or y is 23. That would be our two numbers. Okay. What if a first number plus twice a second number is 6? Twice the first number plus the second totals 30. Find the numbers. We'll set this up like we did our last problem. We just have to convert English to math here. So it says a first number, x plus twice the second number is 6. So I would convert that first sentence to that equation. The second one, twice the first number plus the second totals 30. So again, we have another system. We just have to figure out which variable we want to eliminate. And I'm going to go ahead and multiply the top equation by -2 to eliminate the x's. And we get -2x minus 4y equals negative 12. And then 2x plus y is equal to 30. Adding them together and dividing, we get y is equal to negative 6. If y is negative 6, getting x is equal to 18. A lot of these problems are kind of like the similar structure, just with different scenarios. So let's take a look at a baseball. So 2 players batted 250 runs. The second player hit 14 fewer runs than the first. How many runs did each have? We have 2 players. It says that they batted 250 runs. So the first player plus the second player together, they hit 250. That's how we would write that. The second one, it says the second player hit 14 fewer than the first. So the way I would write this is the second player is y. Whatever the first player hit, if you subtract 14, that's what the second player hit. So if the first player hit 20, the second player, according to this, would have hit 6. The hardest part is converting this here. But if we know y is equal to x minus 14, we could go ahead and use substitution here. And we get x plus x minus 14 is equal to 250. So this would be 2x. 250 plus the 14 is 264. And we can get x is 132. That's what the first player hit. And if y is equal to x minus 14, 132 minus 14 is 118. Typical kind of problem is with a show and with tickets. So let me show you what this looks like. To go to a show, adults and children buy tickets. Three adults and 4 children paid $80. 2 adults and 3 children paid $57. How much are the tickets? Well, if we let X represent the price of adults and Y represent the price of children, we'll do 3 adults plus 4 children, comes out to $80. So 3 times the price of adults gives us total money for adults plus total amount for children equals $80, which is the total amount. And then 2 adults and 3 children paid $57. And once you set it up, we could just use elimination to finish it. We'll multiply this top one by 2, multiply the bottom by -3. And see what we get. 6x plus 8y is 160. -6x minus 9y. Let's see, 57 times -3 is -171. Adding them together, we get -y is -11, or y is $11. And so children cost $11. And if we plug that into one of the originals, we get 2x is equal to 57 minus 33 is 24, and adults would be 12. Okay, what if a jar contains 62 coins, including quarters and nickels? If the total value of the jar is $7.90, how many of each type of coin are there? All right, so well, we don't know how many quarters there are. We also don't know how many nickels there are. But there's 62 coins. So if we add up the number of each type, we get 62 total. And the value of the jar is $7.90. So the way you get $7.90 is you take the number of quarters and you multiply it by how much they're worth. And you take the nickels and you multiply by how much they're worth. And that gives you the total value. So Let's go ahead and figure out what these are. We're gonna have to use decimals here. But if we multiply this top equation by negative 0.25, we'll eliminate the x's. So this will just be negative 0.25x minus 0.25y is equal to 62 times negative 0.25 is negative 15.5. And then we're going to add that with the bottom equation. We get negative 0.2 is equal to negative 15.5 plus 790. Getting negative 7.6. And then dividing getting y is 38. Remember, if there's 38 coins, x plus 38 is 62. 62 minus 38 is 24. All right, a couple more of these. These last two are a little trickier, so let's figure it out here. A chemist needs to prepare 10 ounces of a 9% acidic solution. Find the amount of a 5% solution and the amount of a 14% solution to get what he wanted. Just give me a second to copy that down. All right. So the way we're going to do this is first, let's get organized. It looks like we have three things going on. Let's make a table with concentration, ounces, and then ounces of pure acid. Now, the problems you'll see on the test are going to be similar to these. So if you could just try to understand what we're doing here on the test, you'll be able to do the same thing. So let's start with 0.5%. So concentration is the 0.5%. We don't know how many ounces of that to use, so we'll just put X here. But say if we have 100 ounces and it's 5% acid, that means that there's 5 ounces of acid. So you multiply these together. Similarly, if we have 14%, we don't know how many ounces to use, but 0.14 times Y gives us the amount of pure acid. We want to get 10 ounces of a 9% solution. So we know that 9% concentration is with 10 ounces, gives us 0.09 times 10 is 0.09 times 10 is 0.9. So the way we're going to set this up, and all the problems are set up similarly, what you do is you add the parts. And you set them equal. If we're going to solve this using elimination, we can multiply this top one by negative 0.05. And we get negative 0.05x minus 0.05y is equal to 10 times negative 0.05 is negative 0.5. We're going to add that with this equation. Let's see what we get. Negative 0.05 plus 0.14 is 0.09y, which is equal to 0.4. And dividing by 0.09, getting 4. Let's see, what is this? I'm just going to convert this to a fraction. This is 4 4/9. And then if we want to figure out what X is, X plus 4 4/9 equals 10. So if we do 10 minus that number, we get 5 5/9. Yeah, I'll show you the next one. You'll see that they're all kind of similar. Okay, it is a little tricky. So let's take a look at the next one here. We'll make 180 pounds of blended coffee, selling for $4.39 per pound. We are going to blend a high quality bean costing 550 per pound. With a lower cost bean costing $3 per pound. How many pounds of each should we use? And so this is kind of similar to the last problem. Give you a second to copy it down and then we'll get started. We're going to set it up just like the last one. What we're going to do is we're going to talk about the concentration or the cost per pound. We're going to talk about how many pounds we need. And then we're going to talk about the pounds of each bean. So this is similar to the acid problem we just did. Looks like we're blending two. We have the high cost. We have the low cost. And then we have the blended. So the high cost was $5.50 per pound. We don't know how many pounds of that we need. The low cost was $3 per pound. We don't know how many pounds of that we need. Then it's asking how many pounds of each. Well, if it's $5.50 per pound and there's X pounds, this means that we have 550 times X. That's the total cost of the higher cost bean. 550 per pound times number of pounds gives us the total cost of that type of bean. This would just be 3Y. So if there's 5 pounds of the lower cost, 5 times 3 is $15 is how much it costs for the lower cost one. We want to blend it for 4.39 per pound and get 180 pounds of that. So just like in the last problem, we're going to do 4.39 times 180. And we get 790.2. And then at this point, it's the same as before. You add up these parts, you add up these parts, and solve the system. So X plus Y is 180. And then 550X plus 3Y is equal to 790.2. You have to do elimination. I'll eliminate the y's by multiplying this top equation by -3. And then we'll just solve these by adding them together. So it'll be 2.5x is equal to 790.2 minus 540. And then dividing by 2.5. I'm getting 100.08 pounds of the cheaper kind. Or X is the more expensive kind. And then if we were to plug that back in and get what Y is. See, 180 minus that answer gives us 79.92. How many pounds of the cheaper stuff?